orangutan spends most of its life alone. No pack, no tribe, no village. Just one animal, moving quietly through the trees, mostly by itself. It works. Orangutans have survived like this for a very long time. Now think about a human. Humans almost never live truly alone, not historically anyway. We form families, communities, villages, cities, entire nations, built from millions of strangers who somehow still cooperate. Here's the strange part. Living in a group isn't automatically the smart choice. More individuals means more competition for food, more chances to catch a disease from someone nearby, more arguments over mates, status, and resources. So why did humans go all in on group living? So hard, so completely, that a solitary human today feels almost unnatural? The answer involves predators, babies, gossip, and a trade-off that quietly shaped nearly everything else about being human. Let's dig into it. First, let's talk about the most obvious reason: safety. Out on an open landscape, a lone animal is an easy target. No backup, no warning system. Just one set of eyes, watching for danger, all alone. A group changes that completely. Scientists call this the many eyes effect. More individuals means more eyes scanning for predators at any given moment. A threat gets spotted faster. Everyone reacts sooner. There's also something called the dilution effect. If a predator attacks a group, any single individual's odds of being the unlucky target actually go down, simply because there are more potential targets to choose from. Early hominins were, frankly, not physically intimidating. No sharp claws, no thick natural armor, not particularly fast, compared to many predators nearby. A lone early human, out on the savanna, was extremely vulnerable. A group of early humans was a completely different story. There's real supporting evidence for this pattern across the animal kingdom too, not just in theory. Fish that swim in large schools, birds that flock together, zebras that gather in big herds. All of them show measurably lower predation rates per individual compared to animals moving alone. Early hominins were almost certainly playing the same basic survival math. Strength wasn't the winning strategy. Numbers were. Here's a fun fact connected to this. Some researchers argue that group living pushed hominins toward better communication. It may have been one of the very first pressures to do that. You can't coordinate a defense or warn each other about danger without some way to quickly share information. Safety wasn't the only advantage, though. Food mattered enormously too. Hunting large animals is incredibly difficult for one individual working alone. So is scavenging a fresh carcass before other predators arrive. A group can do something a lone hunter simply can't. Coordinate, surround prey, drive an animal in a certain direction, defend a carcass from competing scavengers, like hyenas or vultures, at least long enough to get a meaningful share of meat. Cooperation, in other words, may have unlocked entire categories of food. Food that was basically off-limits to a solitary individual. Now here's where things get even more interesting. We've actually touched on this exact topic in another video on this channel. Human babies are famously helpless, for a very long time. Much longer than the babies of most other primates. A single parent, alone, would have struggled enormously, keeping a helpless infant fed, protected, and cared for, while also gathering enough food to survive. This is where a concept called cooperative breeding comes in, closely linked to researcher Sarah Blaffer-Hrdy. The idea is straightforward. Human infant care likely wasn't a one-person job throughout most of our evolutionary history. Fathers, grandmothers, older siblings, other members of the group, all potentially pitching in, sharing the enormous burden of raising an unusually dependent, slow-developing child. Researchers sometimes call these extra caregivers allomothers. Under this theory, group living and extreme infant helplessness likely evolved together, reinforcing each other, generation after generation. In other words, human babies may be so demanding, partly because there was already a group there to help, and the group may have become even more essential, specifically because babies were so demanding. Let's talk about something else. Group living provides something a little less obvious: information. A single individual can only learn so much in one lifetime, through personal trial and error. A group is different. Knowledge can spread. One person finds a good water source. Another learns which plants are dangerous. Someone else figures out a clever new hunting technique. In a group, that knowledge doesn't die with the person who discovered it. It spreads. It gets shared. It gets passed down. We've actually covered this idea in more detail in another video about why human intelligence became so unusually powerful. Group living appears to be a core ingredient behind that entire story, not just a side effect of it. Here's a fun fact worth knowing. Some primate species that live in unusually large, complex social groups also tend to have a larger neocortex, relative to their overall brain size. This pattern is sometimes called the social brain hypothesis. It suggests something. A lot of primate intelligence, including a lot of human intelligence, may have evolved to handle one thing: tracking relationships within a group. Who's trustworthy? Who's not? Who owes who a favor? Group living, in a very real sense, may have helped build the very brain that makes humans human. Now, group living clearly wasn't free of costs. It's worth being honest about that. More people in one place means more competition for the same limited food and resources. Disease can spread far more easily between individuals living in close, constant contact. Arguments over mates, status, or leadership can create serious internal conflict within a group. So evolution wasn't simply rewarding group living, no matter what. It was rewarding groups that could actually manage these costs well enough for the benefits to outweigh the downsides. One major idea here is called kin selection, closely associated with biologist William Hamilton. The basic logic is simple. Helping a close relative survive and reproduce can still benefit your own genes, even if it costs you something personally. Early human groups were very likely built around extended families. Parents, siblings, cousins, grandparents, all living and working closely together. Under kin selection, cooperating within that kind of group isn't just generous. It's genetically self-interested too, in a quiet, indirect way. But human groups eventually grew to include plenty of people who weren't close relatives at all. That's where a second idea becomes necessary. This is where something called reciprocal altruism becomes important. An idea closely associated with researcher Robert Trivers. The basic concept is simple. I help you today, you help me tomorrow. Over time, something happened. Individuals who reliably cooperated tended to do better, especially if they could be trusted to return favors. Groups built on this kind of trust could function far more smoothly, with far less destructive internal conflict. There also seems to be a practical limit to all of this, though. Groups can't simply grow forever without new problems showing up. As a group gets larger, tracking every single relationship gets harder. Trust becomes harder to verify. Free riders, people who take help without giving much back, become easier to hide among the crowd. Some researchers argue this is part of why human social structures often settle into a kind of sweet spot. Big enough to gain real safety and cooperation benefits. Small enough that reputation and trust can still be tracked, reasonably well, by ordinary human memory. Here's where reputation becomes surprisingly important too. In a small group, everyone tends to know who cooperates and who tries to cheat the system. Cheaters risk being excluded, distrusted, or denied help later on, exactly when they need it most. Some researchers argue that this social pressure may have played a real role in shaping human behavior over time, gradually favoring individuals who were more cooperative and less aggressive within their group. This connects to something called the the self-domestication hypothesis. We've also touched on this in another video on this channel. Calmer, more socially tolerant individuals may have been more successful, generation after generation. That allowed larger, more stable, more cooperative groups to form and hold together. Now, let's talk about how early human groups were actually structured. Because it wasn't necessarily one single rigid pattern. Many other primates live in fairly fixed, stable troops. The same core members staying together consistently, day after day. Some researchers believe early human social structure may have been more flexible than that, sometimes called a fission-fusion pattern. Under this idea, a larger overall community might split into smaller groups for daily foraging or hunting, then come back together later. For safety, for sharing food, or simply for social contact. This flexibility may have offered real advantages. Smaller groups can move efficiently and avoid overloading a single area's food supply. Larger gatherings can still provide safety, information sharing, and stronger social bonds when needed. It's worth comparing this to our closest primate relatives too. Chimpanzees and bonobos both live in fission-fusion communities of their own, splitting into smaller foraging parties and regrouping later. But human groups appear to have taken this pattern much further. Larger overall community sizes, more flexible movement between different subgroups, and crucially, cooperation that regularly extends well beyond close family members, something far less common in chimpanzee and bonobo communities. Let's cover a few more fun facts before wrapping up. There's more genuinely interesting material here. Fun fact: archaeologists have found strong evidence of shared campsites and communal hearths at numerous ancient sites. Some show clear signs of multiple family units living, cooking, and eating close together, rather than scattered individually across the landscape. Fun fact: some researchers point to the hormone oxytocin, often linked to bonding and trust. It may have played a real biological role in human group cohesion, helping strengthen social bonds between unrelated individuals, not just close family members. Fun fact: anthropologist Robin Dunbar has also proposed something interesting. Human social groups seem to naturally organize into layered circles of closeness. A very small circle of the closest relationships, a slightly larger circle of good friends, an even larger circle of broader acquaintances. This layered structure may reflect deep, ancient patterns in how human social groups have always been organized. So after everything, here's where this leaves us. Humans didn't end up living in groups by pure accident. It solved real, pressing problems. Protection from predators, access to food a lone individual couldn't get alone, shared care for unusually demanding, helpless infants, and the spread of knowledge far beyond what any single person could ever discover alone. Yes, it came with real costs too: competition, disease, conflict. But evolution seems to have favored groups that found ways to manage those costs. Through cooperation, trust, reputation, and eventually calmer, more tolerant social behavior. It's strange to think about something so ordinary: living near other people, sharing meals, trusting neighbors, forming lifelong friendships. All of it is really the direct descendant of an ancient survival strategy, built slowly, generation after generation, out of pure necessity. So here's something worth thinking about. Group living shaped our brains, our childhoods, our intelligence, even our emotions. So how much of what feels like personal, individual human nature is really just an echo of millions of years spent never really being alone?